No organization is responsible for the content of this video. All errors and omissions are the sole responsibility of myself, David Iverson. This video must not be your only source of information. Please attend official USSA educational opportunities. Please download official USSA educational materials.
Okay, so you want to know what is an F factor, and you're not willing to just say, okay, whatever, I'm fine with it, let's move on. You really want to know where it comes from and how you get it. Okay, so I said in one of my earlier videos that race points is equal to racer's time divided by winner's time minus 1 times F. And basically I said that this is by what percent is the racer behind the winner and this is how much does that matter in that discipline. Okay, so in other words, you're going to have slalom, GS, Super G, downhill, and those F values from the front page of the FIS list are going to be currently 610, 870, 1060, and 1330. Okay, and that can change because they're going to calculate that every year, and sometimes it stays the same, sometimes it changes. So what that means is that if you're 10% off the winner in slalom, that's not nearly as bad as being 10% off the winner in downhill. So we'll look at some race results and we'll see that that's true. Okay. But then how do they calculate these? How do they get those numbers? Well, the way that they get those numbers is they start with a goal. And I want to just caution you for a second. I never really saw this completely written out exactly this way. I kind of saw some badly translated stuff from the FIS, and I kind of put 2 and 2 together, and I kind of reverse engineered it, and I kind of figured it out for myself. So I may be wrong. If I am wrong, I invite somebody to send me an email and tell me what's right. So we're going to start with a goal. And that goal is that the goal that they have set in calculating F is that for the world, the average race points should be 60. Why they've decided on 60, I don't know. It's just the decision that they made. So let's go back and let's go to a new sheet of paper here. And so what we're going to do is we're going to say 60 equals, see below, times F. And now that F, that is okay. Calculate the racer time divided by the winner time minus 1 for everybody in every race in the world. Average all of them. Average all of them. And then plug into the formula. Okay, so if I want to know that, what I'm going to do is I'm going to say that if I do 60 equals x times 610 for slalom, x equals 60 divided by 610 is approximately 10%, roughly speaking. I'm not going to go deeper than that. So on average, the average racer is 10% behind the winner in slalom. So what that's telling me is that on average, if you do that, you calculate the average percentage that somebody's behind the winner for slalom for everybody in the world. You plug that into here. You find out that that number is around 10%. You plug it into 60 equals 10% times F, and that allows you to calculate that F is 610. And then for downhill, you have 60 equals x times 1330. So x equals 60 divided by 1330. So that's going to be about, well, if I just do some fancy math for you here, it's going to be 6 over 6 times 2 times 22 roughly. So it's approximately 5%. It's a little bit less than 5%. I could do it on a calculator. You can do it on a calculator. So on average, the average racer is 5% behind the winner in downhill. So to reverse engineer it, what they do is they find out what percentage back is each individual person in the world off of the race winner and the race that they were in, and then you plug that in for x. 60 equals x times f. You solve for f, and for downhill you come up with 1330. For slalom you come up with 610, etc., etc. So that sort of normalizes it, and so that tells you basically how much it matters to be sort of right in there in different disciplines. And again, it has to do with the type of ski race that it is. And tech events, it's easy to make sort of pretty dramatic errors in tech events and still be kind of right in there. But if you make a dramatic error in downhill, then you're going to be pretty far back. So let's bop to the video screen capture and look at some results on the website.
Okay, so here's 8 examples. Here we got a Super G from Bogus Basin, Idaho, and it's a men's race. And down here, the winner got 50.70 points. So that would be, if you add 60 to that, you get 110. There was 52 people finished, so 26 would be the middle of that. So 26 should be around 110, and it's a little bit more. Now remember that we're doing average for the whole world, and so average does not mean median. Average means mean. So there's a difference between the median and the mean, and I'm not going to get into that here. So in this race, the median person had a little bit more than what I was just telling you would suggest. Now we have Bogus Basin, Idaho, Ladies Super G from the same day. The winner got a penalty of basically 90. Add 90 plus 60 gets you to 150. There's 27 competitors, so the median is going to be 13 or 14. So they should have 150, and they have a little bit more than 150. Now we go over to a slalom race in Sweden. And the slalom race in Sweden has a penalty of 27.74, so we'll call it 28. You add 60 to that, you get 88. There was basically 40 people in the race, so 20 should have 88. Ooh, 20 has 68.59. Again, this is probably a really competitive race, and so there's probably other races out there that were less competitive. But also we're talking about mean and not median, and so down here we've got Peep and Victor both scored over 200 points. So because they both scored over 200 points, they're going to shift the mean. They're going to shift the mean this way from the median. There's a little statistics for you. Same race for the women, and we again have a 27 penalty, so 87 should be where we're at, and 24 should be around 87, and so that's a little bit closer, but still it's probably a competitive race. And again, being slalom, you had some people who probably didn't do all that well, and so down here you got some big point holders. So again, they've shifted the mean on the high side from the median. Let's keep going. Giant slalom in Austria. So we have a giant slalom in Austria, an 11 penalty that would make a 71, and 71, so bib 27, or so 27th should have 71, but there 27 has 43. So this is really shifted. This was a really competitive race. So there is a lot of, this was really stacked, basically. The times were just right on in there. But for that race, this race, it's really way off on the low side. But you can imagine another race that you could find where it'd be really not competitive at all, and in a really not competitive race, then this would be well above that 60 race points threshold. Keep looking at it. Here's a 9-point race, so minimum penalty, and so a 69 puts us, again, that's just a stacked race. And of course it was happening in Austria, so you would kind of expect it to be a stacked race. Now the last two examples that I'm going to give are going to be giant slalom from Poland and its national junior championships, and so you're going to have some good people in there, but Poland, you know, they're not a skiing powerhouse. Okay? And you got somebody, the person who finished 44th got it at 256. So the penalty was 55, so 115, and 115 comes in right there, but 44.22. So there, that cancels out, partially cancels out the really competitive Austrian race, is that this race over here is a little bit less competitive, and so the median person is scoring above that 60 race point threshold. And then finally for the women on that same side, in Poland, GS, that should be a 105, so 17 should have a 105, but 17 has a 116. So if I just did this for every single race, if I calculated the racer's time divided by the winner's time, subtracted 1 off of that, and I did that for everybody in this race, and then I did it for everybody in every single race, and then I averaged those out, and then I plug it into the formula, 60 equals that number times F, I would come up with the F values that we use in our ski races. And that is my best explanation for what an F factor is.